Okay, so I'm just going ahead with the pivoting part. I'm taking department, employee's name, and their salary. How the pivot structure looks like. To declare a pivot, pivot must be having some columns. How to declare pivot? Or converting this data frame to pivot. Okay, so there should be some column, and the column should be the department. Department values, distinct values should be individual columns. Let's call it column department. Okay. Index. What should be my index? Let me put index as employee first name. Okay. What should be the values? Let me put salary. Okay. Let me write my entire stuffs over here, putting a print statement on top of it. So this is the structural difference. I have put department as column, so all the data inside department, the distinguished data, it's not repetitive. So I have maintained this thing over here. Department is this, and employee first name, it was, I mean, as it is, it was there. Arijit, Mani, Manju, this way. Now I'm putting the values as salary. When there is a matching stuffs, they will be putting the salary. So Arijit is an IT employee as per the data frame. It's putting it over here. Okay, this is the data representation in another way, a different way. Maybe for this visualization, it's not fruitful. Most of them are null because Arijit is not a BA. That's why the salary is not shown over here. Okay, so this is the another structural way to represent data. Let me change department to index and employee first name as columns. How the data structure would be looking like. So you can see as I put this thing as column, individual first name will be coming into the column just like Arijit, Mani, Manju. So all resources will be represented as column. Sweta, Shifra, Sujit. And the department as well is coming over here in the columns, and whatever are the matching stuffs, they're just putting it over here. Hope that is understandable. Anyone is having any doubt?
No doubt.
Okay. So this is pivot. Another two things we'll be going to learn for today. First one is concat data frame. Concat data frame means if we have two different data frames, two or more, not only two, we will be giving example with the two data frames. So uh, when we will be merging those two data frame vertically, one after another, just like union in SQL. So those can be done by concating two data frames. How we can do that? Before that, let me create two different data frames. Okay, I'm creating two data frames. The first data frame is based on IT. So I'm putting DFIT equal. I'm creating a new data frame, DFIT. I'm just filtering only IT employees. DF dot department equal IT. Okay, IT should be within quotes. I'm also creating another data frame. Suppose BA. equal df dot dpt equal ba. Okay, so I created two different data frames. The first data frame is representing the IT related employees, and the second data frame it's for BA related employees. So I'll be performing. Let me just quickly print both of the data frame. Then I'll be performing the concat operation. It's very simple if you are understanding. But if there is any doubt, please ask me question. Just let me confirm whether the data is coming perfect. Yes. So you can see these are the data frame which are created from the DFIT, and this is the DFIT table. One thing you can see, I created a new data frame, but the index has not been modified because I have created from this data frame. Let me use a copy. Just let me check whether I can. Is there any copy command? Yes. No, it's not modifying the particular index. I'll be checking again. When I'm creating another data frame from an existing data frame, the index should be modified. Okay, there'll be no issue with our, motto over here. We'll be learning the concatenation part. For concatenation purpose, we created two different data frame. Now we'll be going ahead with the concatenation between these two. The first data frame is having this information. The department is IT. Second data frame is having this information. Their departments are BA. Okay. So what is the concatenation? I can just put in this way. Put the first one DFIT concat. Just put the another one. That's it. DFBA. Okay. Let me print the result. Okay. There's an error. Uh, Return object. Concatenation. With concat there is no keyword. Just like, let me just change it. Or I can do one more thing. PD dot. Okay. I'm calling each of the data frame. First this one. Let me do a print statement on top of it. Multiple objects, concat error, type. Okay, got it. It should be declared within a list. Okay, so this is the output. You can see employee ID, employee first time, employee last time, experience, salary, department, date of birth. So you can see the data has been, the two of the data frame has been merged successfully with a vertical way. Vertical means one after another in vertical position. It's not horizontal. Join is a horizontal merging, and concat or union, those are called vertical merging. So the data sets is one upon another. Okay, it's exactly merging in this way. So this is how concatenate works. Uh, we can also do this thing actually, but I think append keyword is also there. Let me just quickly check what I was trying earlier. But it's not showing. No error is also thrown on top of it. It is also working this way. Yes, it's also working. So append keyword is also fine. I can directly do this append keyword, append method on top of one particular data frame. But we have a warning, append method will be depreciated and removed from pandas future version. Okay, so better use concat keyword. Okay, but we can do the similar operation on by the append method. Both are correct. You can see this is the first one, first output, and this is the second output. Those are exactly matching. And while passing inside concat, while passing the parameters. So based on the precedence, if I put this thing earlier over here, then those rows will be inserted. So whichever I am mentioning earlier, those records are inserted first and then the other records are inserted. Okay. Now the difference I'm going to tell you. If you can remember during SQL classes, when we are going to do the union all, intersection, this kind of operation, the first thing was our column should be matched. We are doing the operation between two data frames, the column number, column data type. I mean the columns for both of the data frame should be in sync. Okay. Otherwise, there should be an error. But over here, this kind of concept is not there. We can concat between any data frame. That they should be matching, they should not be matching. But the particular data, I mean concatenation concept they are doing based on the column naming convention. Suppose we have such data type, I mean such column is having a different name. For SQL, okay, let me just tell with an example in Excel, right? This is very, very important concept just I'm trying to deliver. In SQL, suppose we have two different table having two different column naming convention. Suppose ID name and on the second data frame I'm calling it code name in this way. But both of the data type of ID and codes are same. Suppose over here it's 201, name is ABC, 202, name BCD. Over here maybe code is 520, BGD 890. Okay, this way. Now if I'm going to do a union, it will first check whether we have the same number of column with the same data types as well. If there is no same data types, there will be no issue. But there should be or there must be same number of columns for SQL. Otherwise, the concatenation or union will be failing. And it will be doing the union based on the order. So first column will be union with first column, just like this way. The final resultant of union, it should be having the same naming convention of the first datasets column. Okay. So my resultant, I mean, whatever result I'll be getting in SQL, it should be this. First, this thing will be copied. Then this thing will be copied. Okay. But for Python data frame, pandas data frame actually, how they are performing the thing? Let me delete this thing for SQL. Or let me keep it is what it is having. I'm just taking the dataset again just to understand for Python data frame. Okay. Python data frame, they will be matching with the column name. Okay. If I do the concatenation between two data frame, the data frame, the concatenation will not be happen properly because we have different naming convention ID and code. So these two column will not be concatenated. What they will be doing? They will be doing in this way. They will be creating three different column. ID, name should be from first data frame and code should be from second data frame. They will be getting these stuffs over here. Then for name again, name for name, they will be doing the proper concatenation because name is having the same naming convention and the code should be there this way. It's kind of a join, you can say. So the output of the data frame concatenation should be this because of the column name mismatches. Okay. Over here, null value should be there NaN, NaN, NaN this way. NaN. Correct. So this should be the output because they did not get a match between the code and all. So this way the concatenation should be done. Let me show you with a quick example, then I can show you. And one more thing. So if we just go ahead, I want to get a proper concatenation with proper data. Maybe I'll be just needing the union all or just like this. Then we need to rename this kind of column. Before doing the operation, we need to rename the column. Maybe I need to convert the code to ID or ID to code, anything. Then we can go ahead with the concatenation in data frame. Okay. Let me show you with a quick example over here. I'm just going to modify the name. Okay. Let me add a new name. Okay. For department, I'm just applying a new name. For DFIT, let me introduce a new column. Okay. So DFIT table, I'm going to introduce a new column. Suppose the column's name is department. Okay. I'm not putting DEPT. I'm including a new column department equal IT. Same thing. I'm doing it over here. Let me print once more time DFIT. You can see a new column will be introduced for DFIT. Yes, we have department as well. Let me delete this department. So we know how to delete it. So delete statement means drop statement. I'm going to create DFIT1 equal DFIT dot drop syntax. I'm going to drop DPT where axis equal 1. I hope you can remember this thing. Let me quickly print DFIT1 as well, just to ensure. Yes, so the department is not there in the final data frame. Okay, now I'll be joining DFIT1 with DFBA. As I mentioned over here, they will not be checking the order. In SQL, they are checking the order. First column should be union with first column. Second column should be union with second column. But they will be searching for the same naming convention. They will not search for the orders. I can arrange the orders over here. There will be no issue. But they will be searching for the name to be concatenated. This is the difference. Let me do the concatenation, then you can understand. So over here, there is a slight order change between DFIT1 and DFBA. Okay, the depart after salary there is DEPT column. Over here after salary there is DOB column. Then I'm mentioning DPT as department. Let's see what happens. I'm just going to pull the same thing over here, but over here I'm putting DFT IT1. So you can see they are not, as the department naming convention is modified over here, they are not able to properly union. They are creating department as well as DEPT. From the first data set, as we are having department column, that is why we are getting this information. From the second data set, we are having DEPT column. So it's introducing another column over here with DEPT and putting the value. What data is not there for each of the column, they are passing null value. Okay. So this is the main fundamental change over here. I hope you can get it. Any doubt so far from anyone? Is it fine? The concept is clear. Please tell me. Okay. Thanks, Durga. The last topic for today, as well as Python transformation, is merging the data frame. Merge means merge keyword is being used for horizontal merge between two data frame. It's just like a join. Whatever we are doing for SQL joins, the same thing we are doing over here. The joining concept I have described at that time with lots of exercise or examples. So joining concept I'm not going to show you. I hope you can understand it. So I'm directly going to the syntaxes. Before going to the syntaxes, let me import two different data frames from two different CSV files. I have created two CSV. One is called student. Okay, so this is one particular CSV file where we are having student ID, their class, their name, and teacher ID is also present. Means the particular student's class teacher ID. Okay, and we have another data frame called teacher. Let me open the same. Yes. So the teacher CSV is having teacher ID versus subject, this data. So if we perform join between teacher and student, we can get the extra column subject. Okay, we can join based on teacher ID. Teacher ID is a common column between each of the data set, and we can get the subject column at the resultant output. Okay, similar concept of join. So how to do the join? Let me import those two data set first, those two CSVs, student and teacher. What is teacher student? Let me show you. Let me close this. Okay, it's the final output they're providing. Okay, so let's establish this result in our data. Okay, I'm going to import both of them. For this thing, I only need pandas, NoSQL Alchemy, because the source system, it's not a. I'm just going to put this thing as, I'm just commenting this thing out. Comment out means if I put comment out means this hash. So if I put this comment out lines means when I'll be executing this, those will not be executed. Okay. I'm directly starting my coding part over here. So I'm going to declare TF student, data from student. equal pd dot read CSV, and I'm calling the particular file from here. Just read the path, copy as path, pasting it over here. One more thing I need to change, this backslash I need to put twice. As I mentioned, the first backslash will be working just for an escape character, and the second one is the original one to read the folders separation, hierarchical separation. Okay. Similarly, I'm doing for teacher as well. DF, this thing will be teacher. The student should be updated to teacher. Okay. So we created two different based on two different CSV, two different data frame based on two different CSV. Let me quickly have a print statement on top of each. So it's successfully imported. We have this many teachers, this many students information, and each of the teacher is learning which particular topics or which particular subjects it's mentioned in another data frame. Now let me perform the merge operation here. How to do that? So I'm just taking a final data frame called df pd dot merge. Okay, I'm calling the data frame 1. Second data frame as well. Okay, on based on which particular column you will be joining over here, teacher ID. So the parameter we need to pass in this way, on equal teacher ID. Okay, and if we do not mention what kind of join, we can mention the join with the keyword over here. But if we do not mention what kind of join we are going to perform, then by default it should be inner join. Same thing for SQL syntaxes as well. Let me do a print statement on top of df and see the output. So you can see it's properly joined, but it's a inner join. Okay, because in teacher table we have some extra records than that of student. We can also mention the join type over here in this way. How? How is the parameter? It can be inner. You can put inner join in this way. You can put simply join. Both of the cases, it should be taking inner join only. Okay. If we want to perform left join, put left join, LEFT. Or simply put LEFT. It should be running. Inner join and left outer join should be almost same output because, okay, one more thing. The precedence or the order we are mentioning inside merge table, DF student I have mentioned earlier. So this is my left table, this is my right table. So based on the order I'm presenting it over here, it will be taking this thing, left table and right table. If I put right over here, then you can see slight difference because the right table is having more records. So we can get some null values. Yes. So right table we have teachers for geography and statistics, but there are no students allocated with the subject. So that is why null values are passing over here during doing the right join. Okay. One more thing just I want to say before we are closing the topic. Suppose we have two different columns. In join we can see there are two different naming convention of columns. Suppose I'm putting it over teacher code or teacher CD. Okay. The first table means the student table is having the data teacher CD, not teacher ID. Let me save it. Okay. Let me close this two line because the join should be throwing error because I have changed the column name in student data frame. Let me run this thing first. Here you can see the first table is having teacher underscore code CD and the second is teacher underscore ID. But the data is same. I need to join based on these two columns. Then I can mention in this way over here. Let me now comment this thing in. Okay. So instead of on, we can put left on. Means from left table, what should be the column? It should be teacher CD. And I also need to specify the right on. It's the right table, which is the joining column. It should be teacher ID. How? Right join is fine. What kind of join we need to perform? You can put it over here. So you can get similar output what we have received. Okay, there is some issue. What is the issue? Teacher ID. I put a wrong spelling mistake. I mean, yeah, it's a spelling mistake. Yes. So this is the output. Okay. I hope this is understandable. Based on that, maybe I do not want both of the teacher code and teacher ID to be available over here. So I can slice the data set. I know how to slice it. So we can slice it properly. Okay. If required, you can see after join, the particular things are short data type. It's not integer anymore. Student ID it was 1 earlier. Now it's 1.0. So we can typecast or we can do the as types keyword to be applicable over here. Okay. So this kind of thing you can also impose when you'll be doing the thing. Okay. So this is how join should work. Tomorrow I'll be showing the data loading part. So when our data is ready, means our transformation is completed. In ETL, I told ETL, extraction from external source system. Transformation means when the extraction is completed, we can do the transformation part. When the transformation is completed, we are ready to move the data into final data warehouse where the business stakeholders, the visualization team can take the data from the data warehouse level. So tomorrow we'll be doing the same steps. We'll be loading this data into some data warehouse part. Okay. Along with that, we can also go ahead with some visualization technique. How to visualize, just like a reporting tool is there for the visualization purpose of data. Maybe it's a line chart, maybe it's a different bar chart or just like this. Based on the independent and dependent variable, we can create this kind of charts and graphs. So those things we will be learning in tomorrow's session, the data loading part at the target site. So after this Python loading part is over, in loading part based on Python data frame, then I'll be giving you a particular exercise to be solved. It's similar kind of exercise what I have given during SQL classes. So I'll be expecting that you to solve that particular exercise at your own Monday classes, I'll be also showing the Git concept. So whatever exercise you are covering, push this exercise in Git repository, in your Git repo. Okay, I'll try to check it from there. But please try to solve it. I'll be giving this exercise on tomorrow's session. It is very simple, just like the entire ETL concept. We'll be taking data from somewhere, we'll be doing the transformation, and we'll be loading the data at the output. So tomorrow, the rest of the things will be learning those stuffs, and uh, Monday or Tuesday, you will be trying to solve this exercise by your own. So I'm expecting from each of you to solve this exercise. It's very, very simple, but where you are stuck, please tell me. I'll be helping you out. Okay. Okay. Any doubts so far from anyone before we close the class for today? Is it clear?
Yeah, it's clear from my end.
Okay. Thanks, Vikas. I hope for others as well. It's clear. If not, please tell me. Thanks, Durga, for confirming. Okay. So I'm going to close this session. Let's connect on tomorrow. Thank you, everyone.
Thank you, sir.
Thank you. Thank you. Bye bye.